Alrighty, we'll go ahead and get started and other people will wander in. Oh no, Elijah, I hope you're all right. Jeez. I feel like a lot of my students have been getting injured, so stop. Just take good care of yourselves. No, I know stuff happens, so. A couple things. I have your exams. I have two people who were gonna turn them in, I think, today. So I'll check in with them at the break. I just don't want to give them back if people haven't turned them in, if that makes sense. So I'll check in with them, and if they're good, then I can pass them back. You can see your scores on Blackboard. So I got those in. I focused on those, so I did not get to score your small assignment from last week. I'll put that done this week. Let me see. Oh, yeah. I was saying this to people before class. If you tried to do the IRB assignment, what you will discover is, me not checking that a website that's always been free doesn't suddenly start charging you all $50. What? So I did some research and I found another free training you can do. As far as I know, you don't have to register for this one. Cool. So just go through the lessons. It should give you some sort of certificate. It's saying it takes like hours to complete some of these. If you read fast, they're gonna skip through. But so that one can be done in place of the other one. I don't want y'all to pay because God no, I don't want to pay $50 to get trained. So let's see what else. Okay, so because of this once a week class and it has a little bit of a chaotic schedule, next week you'll actually get exam 2, which will cover what we covered last week, what we're covering tonight, and what we're covering next week. And again, the reason why you have so many, like such a quick turnover, is I'm trying to keep the amount of information on each exam concise, right? 3 chapters. And so this week is the last week that we are actually going to be dwelling in stats. So thanks to everybody for kind of hanging in there with me while we did this. I know this is nobody's favorite chapter, but I swear this will come in handy once you're doing your group project. So today we have a lecture about some of the other things we can do to make scores usable. And then you have an assignment related to that. And we'll just sort of play it by ear, whether we do that before or after the break. And then what we'll do for our last hour-ish is that we will go over to the computer lab and I'll teach you all how to do all this in SPSS. So, and then you'll see how easy it is in SPSS. That's what you all will be using to analyze your data later in the semester. So it's good to start learning it now, getting that under your belt. Next week, we will start doing assessments and we will start learning about specific assessment as well. Couple consistent questions I've been getting about the group project. You don't have to overthink it. I think a lot of people are like, wait, I have to do like a Nobel Prize winning study. All you're doing is creating your questionnaire. You use those techniques that we talked about in the class last week, right? Most people are probably going to create something you're going to answer with a Likert scale, right? And then decide how many items you want to come up with. Do you want 10? Do you want 15? Do you want 20? Do you want, I don't know, 17? You can choose, right? And then you're going to be giving your participants facts. You're going to be giving them a questionnaire that measures the same thing you're trying to measure, but it can be slightly different. So for example, I know I have one group who's doing body image in athletes. You don't have to find another scale that measures body image specifically in athletes. You can find another scale that just measures body image. And then something that will have divergent validity. And if you're sort of like, I don't know what to use, I can help you people often use something like anxiety, depression, just because those are related to a lot of things, but shouldn't be highly correlated to something else you're measuring. But you might want something more specific as well. And then you'll also give them demographics, which are simple like age, gender, race, if you want to ask about sexuality, if you want to ask about relationship status, grade level, things like that. How you give those is going to be up to your group as you start to work through that IRB together. You can print them out, and I can put them on the psychology department's dime and go around and hand them out to people. You can put them in a Google form and have people answer it that way. Or you can have people go through SONA systems so they can get credit for courses, and you can either link them to a Google document, or SONA has its own Google form, SurveyMonkey like system where you can put your questions in there and they can answer it right within the SONA platform. And each week from here on out, I'm going to try and leave some time, or maybe even do some time like after break each day, for the groups to touch base and start thinking about some of those things, and me to kind of float around and help. So any questions about the group stuff now that I've hopefully clarified a little bit? All right, and I've been answering questions on your individual meetings. I've been having a blast meeting with y'all. I think about half of y'all have met with me. So just remember to set up an appointment via my Calendly and we can chat. I talk about my cat sometimes he photobombs. It's fun. Alrighty. So today we're doing chapter 7. One of the things I want to say is thank you all for my patience, with your patience with me last week. Typically I can just pick up a lecture I've written before and go with it, but I had forgotten that the last time I taught it, I had COVID, and so I was like filling stuff in on the screen because I didn't have a board to write on. So it was a hot mess. Instead, what I did for this one is I went through, made sure everything was correct. I put in the figures and tables whenever I could to make it easier, so you're not having to like refer to your book. And I've done that for the other ones going forward as well. So hopefully this one will be much easier, much clearer. And again, thank you all for hanging in with me. So what we're going to talk about today is, okay, you've gotten your raw scores, right? And you can get like a mean from it. How do you turn that into something that might be meaningful on a metric that's used in the assessment world? So one of the things that your book talks about are criterion versus norm reference tests. Norm reference tests are just what they sound like. You compare everyone's score to a norm. And so how did they score versus whatever that norm is, whether it's an average or maybe a range. So you can compare the set of test scores to the peer group or the norm group. If you make it explicit you're doing this, say like in a classroom, this can be unhealthy. This can create competition between students and sometimes have like an unhealthy environment. You can also do what's called a criterion reference test or assessment. And that describes a specific set of skills, tasks, or knowledge that the test taker can demonstrate. For example, taking a math test, right? These are the skills they want you to be able to do. So it compares the student with a criterion rather than with the other students. And then you can use those results to make individualized programs, whether those are an IEP for a student for instruction in K-12, whether that is a client who's sitting across from you and you're going to start recommending therapy based on the results that you got, right? And these can be used for diagnostic purposes for that reason. So you're comparing it to the criterion of like, do they meet the criteria for that diagnosis? Or do they have enough symptoms that we check off that we can diagnose them with that? And that in and of itself is a criterion. So you're identifying problems that can be remedied. These have also been used, particularly norm reference, to compare schools to each other. And in particular, that's one of the things the No Child Left Behind Act tried to do. And so these are some examples of norm reference and criterion reference tests. So norm reference are a lot of things you've probably taken, like the SATs, the ACTs. If you ever take an exam in one of your college classes and it's scored on a curve, that's norm reference. There are some personality inventories. IQ tests have very specific norms. They're like by gender and age. There's also by race. It's very specific. There are also career inventories as well. Now, criterion reference, again, there's going to be some external criteria you're relating to. So like the Beck Depression Inventory has a cutoff. I think it's above 30. You have severe depression, basically. If you had a college writing entrance or exit exam, right, there's some sort of criterion they're comparing you to. A driver's license exam, you got to get a certain score, right, in order to pass. So that would be true both on the written and on the practical, right? I had a fun one in the middle of my driving test. Someone decided to try to cut me off. So like I went to change lanes and the person who hadn't been in my blind spot like a second beforehand wasn't, but I caught it, didn't hit anyone, but I was like, oh God, I'm gonna fail. But she was very understanding, my tester. I appreciated that. There are alcohol screening tests that are going to compare to something like, you know, what is the blood alcohol content under which or over which you should not be driving. For every state, I believe now it's 0.08. And then college exams against a standard. This is what I do. This is what you all got on exams. I don't look at how did yours compare to Jim Bob's compared to Mary Sue's. Just like, okay, if you get above a 98, you're somewhere in the A range, right? If you get above an 80, you're somewhere in the B range. And so you probably have run into a decent number of criterion reference tests as well. You can also get what are called derived scores. So again, last week we were talking about raw scores. These are just the scores people got, right? So for example, this test was out of 100, but I have other tests I give that are out of 50, right? So your raw score out of 50 might be 49, but if I wanted to talk about like that percentage you got, right? I have to do some conversions to be like, you got a 98%. Right, and that's what you're doing in derived scores, and there's a whole host of them that you can use that we're going to talk about. Percentiles, standard scores, developmental norms, and we're going to start with percentiles. So percentiles are the percentage of people falling below the obtained score, and it ranges from 1 to 99. 50 is the mean, maybe not surprisingly. And we talked a little bit about percentile rank last week. One of the things people confuse about this is, are percentile scores the percent you got correct? No. What percentile scores are showing is how you did compared to other people. So if you're in the 50th percentile, that doesn't mean you got 50%, that you bombed the test. It means you got an average score on the test, that about half the people are below you and half the people are above you. If you're up in the 99th percentile, that means, I mean, you still could have gotten, you know, I don't know, 180 out of 200 or something, right? But because like 99% of the people did worse than that, you're better than 99% of the people. You're in the 99th percentile. So what you do to get the percentile, and I think I have this formula. No, I didn't put it in there. That's okay, because I'm never going to make you do it. But in order to calculate it, just like in your head, so you know this, you divide the total frequency into hundreds. So like 100% is usually how we conceptualize things, or a percentage out of 100. And then basically you indicate the particular score beneath which a defined percentage of scores fall. And so with percentile rank, the question you're always asking and answering is compared to what? Compared to whom, basically. And so this figure shows you how those percentiles would map onto the normal curve. Right, so the vast majority of people are gonna fall between the 80 and the 20 here. And again, a 50 doesn't mean you're failing, a 50 means you're average. And what you'll notice is that not very many people, if you consider like each of these is a person, right? Just like the histograms we drew last week. So most people are here, right? When you get out here to like the 99th percentile, there are not very many people there, right? And that's on purpose. The normal curve sort of represents the fact that the vast majority of people typically fall in some sort of average range. And once you start to get out from that range, you don't see as many people there. So by the time you're 2 or 3 standard deviations out from the range, from the mean, it's pretty rare. You're sort of deviating from the mean at that point. That's why we call it standard deviation. But again, just really like this because it shows really well how all those percentile ranks kind of squish up together in the middle there. All right, so now we're going to start talking about standard scores. And so standard scores often vary just by whatever the test creator prefers. Okay, so in some ways they're arbitrary, but once you've chosen a standard score, there are guidelines for it, right? But for example, we could take the SAT and put it on Z scores, right? And then it would range, your scores could range from like negative something to positive something, right, on the SAT. I think they partially don't do that for psychological reasons, so people don't score a negative, right? But basically you can take any existing score and convert it to one of these standard scores. And so the first one we're going to talk about is Z-scores. Z-scores are really a way to conceptualize sort of where people are falling relative to each other, thinking about the mean quite a bit, because what happens with the Z-score is the mean becomes 0. So this line here is Z-scores, and your mean becomes 0. And then basically your Z-scores end up matching up with your standard deviation from the mean. And so if you're 3 standard deviations out from the mean, you'd have a Z-score of 3, right? So they basically go from -4 to +4. And the way that you calculate a Z-score is you take the person's score, subtract the mean, and then divide that by the standard deviation. And we're going to practice these later. Basically, what Z-scores let us do is understand where that individual falls on that normal curve. And so if a score is equal to the mean, what would its Z-score be? 0, right? And if a score is more than the mean, the Z-score is positive. Score is less than the mean, the Z-score is negative. And this just shows you standard deviations, Z-scores, and percentiles all in the same figure, so you can start to wrap your head around how do these things go together. What I've seen Z-scores used the most for is if you are doing calculations on a big data set, and let's say you have one measure that's on a Likert scale of 1 to 7, and one measure that's on a Likert scale of 0 to 4, right? But they're measuring something similar, so you want to combine them. And there are ways that statistically you can combine those scores, right? And so what people will do to essentially get them on the same metric is put them in Z-scores before you add them up, because then they're both on this metric of how far from the mean you are. So this is rule number 3, that Z-scores are golden. Z-scores help us see where an individual's raw score falls on a normal curve. And they're helpful for converting a raw score to some of the other scores we're going to talk about on the other slides coming up, the other derived scores. This is why we keep in mind that Z-scores are golden, and they can be used to help us understand what the heck these other scores mean, basically. And this is, again, another nice diagram, got lots of them on here. Where again, you can see standard deviation from the mean, let's see sort of the cumulative percentage, which is equivalent to the percentile rank of how many people you get to if you look at that score. Like, all right, let's say I want to look at someone who scored 1 standard deviation above the mean. Well, we know just like if we added up all the people under the curve, literally add up the area under the curve, that's going to be about 84% of people that they did better than. And again, here's your Z-scores. And then what we're going to talk about next are T-scores. First, it's going to do the Z-score to percentile. So you can take a Z-score and use it to calculate the percentile. So you find your Z-score, and then you can either look at this graph and be like, what's the approximate percentile? Or in your book, in Appendix F, way in the back, find it. That's E. There we go. There is a table of like, okay, if you have this Z-score, what percentile is it? So you can use that to get an approximation as well. Or you can use this fancy dancy formula that I'm never going to make you use. But I just wanted to put it on there so you saw, woo, there's a way to do this mathematically. Unnecessary for y'all to learn. And so again, you can kind of eyeball it on here, or you can use the appendix in the back of your book to say, let's say I have a Z-score of positive 1.2. I can flip to Appendix F, way in the back. It's on page 329. And all right, I'm gonna look for positive 1.2. The percentile is 88.49%. So again, fairly simple conversion. And help you wrap your head around, what do these scores mean? Where does this person fall relative to other people? So in order to convert to some of these other standard scores, we are going to first get our Z-score and then plug it into this formula. And this formula here is going to be the same regardless of what type of standard score we're converting to. The only thing that will change are the standard deviation and mean of the desired. But you're going to take your Z-score, multiply by that standard deviation, add the mean. Again, that's probably easier to conceptualize in practice. So we'll kind of look at this. All right. T-scores. T-scores are used quite a bit for personality tests. So for example, if you take the MMPI, a lot of their scores are on T-scores. And then T-scores, the mean is 50 and the standard deviation is 1. So again, let's take the same Z-score we were just looking at, 1.2, right? Positive 1.2. And let's start looking at some examples here of what it is. So if we want to do a T-score, right? Then we are going to go back one slide and get our formula. Okay, so we're going to, for all of these, we're going to be doing a Z-score times the standard deviation of desired score, which I'll just abbreviate DS, and then plus the mean of the DS desired score. All right, so for a T-score, we just looked and we said, okay, so the mean here is 50. All right, and our Z that we're going to use here for our example is 1.2. And then the standard deviation is 10. So this one, because it's 10, I don't even have to calculate it, right? So we know that that's going to be 12 plus 50. So our converted T-score for our Z of 1.2 is 62. And again, other scores will have other means and standard deviations. One that we'll see and work with quite a bit are DIQ scores, are basically intelligence scores. And so here we know that the mean is now 100. We've still got our Z-score of 1.2, but now we got to multiply it by 15. Okay, so here's where Dr. Myers needs her calculator. So I can only do so much in my brain. All right, so 15 times 1.2 is 18. Plus 100 is 118. Which makes sense, because if you start to think about it as a Z-score of 1.2 is just above one standard deviation above the mean, right? We know if you were one standard deviation above the mean on an intelligence test, you score a 115. Because you're a little over that, it's a 118, right? So this stuff starts to make sense. I realized in my notes I have a little more context for T, so I'll give you some background on T. It's technically called McCall's T. And this was established in 1939 by a guy named McCall, shockingly, right? The last name. So in psychology, as in many sciences, if you do something new or groundbreaking, they name it after you. They also do this in some sports like gymnastics. You're the first one to do a move, you get it named after you, right? And so he was the one who was like, we're going to put the mean at 50 because that's the 50th percentile. And then I'm not really sure why he decided the standard deviation was 10, other than your max score, if you're like 4 SDs out, is going to be about 100. But that's what he rolled with. So again, just a little more background. Stainings are another one here. Here, the standard deviation is 2, the mean is 5. These are mostly used for what's called achievement testing, which we'll talk about next week. Achievement testing basically measures how much of what you should be able to do you can do. So like, how are you doing at reading? How are you doing at math? Achievement testing is used quite a bit, not only sort of within the schools, if we're thinking about like SOLs, things along those lines, but also within like testing for learning disabilities. So this person is really smart. We'd often give an IQ test along with the achievement test, but you know, their capacity, their ability in math is not showing up in their achievement in math. So maybe they need tutoring, maybe they have a specific learning disability for math that exists. It's called dysgraphia, right? Oh no, sorry, that's one's dyscalculia. Dysgraphia is writing. And so that allows us to do that. But for stainings, what we have here, we still got our 1.2 for our Z-score, right? Our standard deviation here is now 2. And we're going to be adding it to 5. And so I'll start going sideways because I have a little more room when the digits are smaller. Right, so we're going to get 2.4 plus 5 is 7.4. And sometimes you'll just see these rounded. So then that would be like approximately 7. And again, Does a staining give us any other context if we're not looking at an achievement test? No. Does an DIQ give us any more context if we're not looking at an intelligence test? No. Right? So part of the fun of assessment is figuring out which of these metrics you're working with, depending on the assessment instrument you're using. Maybe my definition of fun is different than y'all's. So again, this starts to look at a bunch of these together. So we have stainings here. You can look at the percentage in each staining. Here's your T-scores. Here's those Z-scores. There's your percentiles. And if we go way up here, there's our standard deviations. Okay, so again, starting to wrap our heads around how these all just mean the same thing. They're just used differently on different tests or different types of tests. All right, STEM scores are used with some personality inventories and questionnaires. Again, pretty straightforward. 1.2 times, I believe it's 2.5 for this one. No, 2 plus 5.5. So pretty close. I don't know why the STEM people didn't just use stainings. I wasn't there. I would have been like, just use stainings. Right? But back then they probably wouldn't have listened to a woman anyway. Let's be honest, I couldn't have gotten a PhD, or it would have been really hard. There are literally, if anyone takes history of psych with Dr. Jackson, there were literally women who like were trying to work in psychology, but they weren't allowed. So they sneak into conferences and hide under the tablecloths, or they literally like draw on mustaches and sneak in. Like, it's comical, but it's what they had to do to participate in the field. So then this one would be 7.9, and again, you round here, so that's about 8. Alrighty, NCEs are like percentiles that kind of range from 1 to 99, but they're more evenly distributed. If you remember, if we look back at our graph here, percentage percentiles really bunch up around the mean, right? And so the distinction with NCEs is they kind of spread that out. So these are used for educational tests. Again, 1.2 times here, our standard deviation is 21.06, like you do. And again, we've got 50 here. All right, so now I, again, need my trusty dusty phone calculator. So 1.2 times 21.06 is 25.27 plus 50, which would be 75.27. Okay, cool. Then we get to some of the ones again that you might be a little more familiar with just because you've taken some of these tests, right? So if we look at the SATs and the old GREs, the new GRE uses a really weird system that I still don't understand. So when people tell me their GRE score, I'm like, is that good? Like, I don't know. But the SAT does still use this metric. And here, the mean is 500. The standard deviation is 100. 100 plus 500. So then we get 120 plus 500. So this person would have gotten a 720 on whatever part of the SAT that is. And again, because, did I add it up wrong? Should be a 620, shouldn't it? Yeah, thanks. I appreciate the facial feedback. I am that person too. Like, my friends have always told me when they're presenting, they like when I sit in the front row because I'm a nodder. They're like, that's great. And I'm like, I don't even realize I'm doing it. Cool. The ACT, again, has to be its own thing, has to be weird, right? I liked the ACT better. I just felt like it actually tested my knowledge instead of how well I took a test. That's not the case for a lot of people. All right. So the mean here is 21, standard deviation is 5. God knows why. Again, it's very arbitrary. Anyone can kind of choose whatever they want. But the nice thing, once you have a z-score, right, you can convert to any of these pretty easily. So then we have 6 plus 21, which is 27. That's a pretty good ACT score. The top ACT score is 36. Then, on top of all of these options, there are what they call publisher type scores. And so sometimes the person who publishes a test is just like, I'm going to pick my mean and standard deviation. None of the rest of these are good enough for me. But, okay, cool. But as long as they give them to you, you can still convert the z-score with this exact same formula. So this, I think, was a really nice little example I found online of essentially how to compare these types of things, right? So we can look at, if someone gets a 25 on the SAT and someone else gets an 1150, or sorry, on the ACT, and if you got a 25 on the SAT, it'd be really bad, right? Again, I think you get 200 points for just putting your name on that. But someone else gets an 1150 on the SAT, right? You can kind of graph it out, you can calculate it out to see who got the better score, basically. And what you can see, and you can even just look by, how many people are below them, how many people are above them. Zoe's score on the ACT is actually better than Mike's. Not by a ton, but it's better. And again, here you can see these people are reporting different standard deviations and means. So who knows? Maybe the testing people just changed them. I don't know. Okay, so there are also what are called developmental norms. These are often used in particular for things like intelligence and achievement tests, because we don't expect, say, a 4-year-old to be able to do what an 18-year-old can do, right? Just developmentally, they're not there, right? My daughter is so funny. So she'll just kind of say yes to anything you ask her. Like, oh, did you do the 100 board today at school? Yeah. Did you do advanced calculus? Yeah. Like, okay, you just don't remember what you did, and that's okay. You're still like forming memories, right? But we know that advanced calculus would not work for a little 5-year-old mind, right? So what we do here is age comparisons, where we're comparing to others at your same age. This is done quite a bit with physical attributions. So for example, we can look at your weight for your age and your height for your age. So for example, if a 10-year-old weighs 78 pounds, what percentile are they in? There's a fancy way we can convert this. Again, not going to make you all do this, but basically you can use norms and calculations to say this one's in about the 40th percentile. That's within one standard deviation of the mean, so they're pretty much average on weight. This is fun. When your kiddo was born in the 90th percentile for length, they call it length at first because you get it laying down. It's not height yet, right? So my kiddo has remained ridiculously tall, but not as much as Dr. Slipka's kiddo, who is a year younger than my kiddo, but almost as tall. So we just have fun, like talking about our giraffe children. And then there are what are called grade equivalents. So instead of looking at age, we can look at your grade in school. So for example, if you're whatever 5.6 in grade is, right? You take the school year and divide it into tenths, and you're, a little over halfway through the school year. If you're reading, let's say, at a 5.6 grade level, you're right on target. You're average, right? And usually this is not a statement about how much better or worse you are than other kids, just sort of like relative to other kids, are you developmentally where you're supposed to be? Right, and you can have kiddos who are really gifted in these areas, right? You can have a sixth grader who's reading at the 10th grade level, right? And that becomes a challenge for the teachers of how do I keep this kiddo engaged, but also all the kiddos who are reading at the sixth grade level, like they're sort of expected, right? One of the things that we look at when we're looking at these is the standard error of measurement. And so when we're looking at the standard error of measurement, this is based on the reliability of the test. So this is one of the reasons why we talked about reliability a couple weeks ago before we got to this stuff. And so this tells you how much error there is in the test, and ultimately how much any individual score might fluctuate due to that error. So remember, we talked about there's lots of different sources of error. So this is the formula where you take the standard deviation of the score you're using. So like if we were looking at t-scores, we're going to take that 10. And you times it by the square root of 1 minus whatever the reliability of the test is. And again, this is published by the publisher for those tests. So if you get a t-score on a person of 60 on a personality test and the reliability is 0.84, you can then calculate this out, where 1 minus essentially 60 gonna give it'd be like 0.6, but give you 0.4. And so then you get an SEM of 4, a standard error of measurement of 4. That means 68% of the time your score is gonna fall between 56 and 64 if you scored a 60. So this is basically, again, kind of looking at a standard deviation like unit. 95% of the time your score is going to fall between 52 and 68. So you can see how close you get. So again, here's that 68 for one standard error above and below the mean. Here's that 95 for 2 standard errors above and below the mean. And then you can get up to 99.5. And again, similar to percentiles, much bigger jump here than here. We have to look at what all we got here. Okay. I am going to need to take a quick little break just to hit the bathroom. So you guys can go ahead and take a break too. Take about 5 or 10 minutes if you want to just sit here, you can, and then I'll be back as soon as my stomach is not back here. I'll be right back.
No, I'm saying, I think to actually do it. Where you go with yourself? I'm gonna find the foot and then I asked to so I'll be back about this. I'll go. Yeah.
Okay, y'all, thanks for your understanding. I have some gastrointestinal issues, usually when I teach they're not an issue, today was different, so again, thanks for your patience. So this gives you an example of what that standard error of the mean looks like. When the reliabilities are different, right? So if you have a higher reliability, if you're in that 0.9 range that we're looking for in tests we're giving in applied settings, like in therapy or testing for learning disabilities, you're gonna have a pretty small standard error measurement. If you're just in that acceptable range where your reliability is like 0.7, you're gonna see there's a much larger standard error of measurement. And this is why sometimes if you have a test, an assessment, a questionnaire that doesn't have good reliability, it can actually be harder to find significant results. Because you've got so much error in there that you're not going to get a clean, statistically significant number. You can also have something called the standard error of estimate, and that gives you a confidence interval around a predicted score. And this is based on the scores you've received on one variable. You predict the range of scores you'll receive on another variable. So the example that they give here is if you know your high school GPA and you know the correlation between high school GPA and first year of college GPA, you can predict the range of GPA that you were likely to get in your first year of college. Now, that's not always the case, right? A lot of stuff can happen. You might have trouble adjusting to being outside your home. You might have to work 2 or 3 jobs to pay for college, right? But it at least can give you an estimate. So then this is rule number 4. Don't mix apples and oranges. And that seems a little silly, but basically what it means is that as you practice various formulas in class, it's easy to use the wrong score, mean, or standard deviation. So like, for example, if you're supposed to be using the DIQ, then we don't want to use the raw score, right? Or you don't want to use a T-score. So whenever you're asked to figure out a problem, remember to use the correct set of numbers. Don't mix apples and oranges, or you'll get a wrong answer. I mean, y'all are smart people. That's pretty intuitive. Now we're going to start talking about scales of measurement. And measurement itself is the application of rules for assigning numbers to something. Can be objects, can be abilities, right? These are specific procedures we use to transform the qualities of those attributes into a number. And so we look at a whole host of different things, and some of them are more easily quantifiable than others. So gender is typically measured as either male or female, although that definition is broadening, right? But if you look at something like achievement, it can be measured on a scale that has a much larger range of scores as just 1 or 2, right, for gender. 4 different scales of measurement have been created to help us define how quantifiable something is. And the type of scale you use is intimately related to the type of instrument that you choose. So these are the properties that we'll be looking at as we look at these ideas. So magnitude is moreness. It's a weird way of putting it, but that's what it is. A scale has magnitude if we can say that in a particular instance, that attribute represents more, less, or even equal amounts of a given quantity. So can you all think of examples of things that have moreness? And it can just be from everyday life. It doesn't have to be any kind of assessment measure. We looked at one last week for our example, if that helps. So we wrote up on the board. Yeah, height, right? So if there's someone who's 6'4" and I stand next to them and I'm only 5'4", right? You can tell that they have more heights than me. And in fact, that happened when I was in high school. We did acting Shakespeare. I played Friar Lawrence, like you do. And our Romeo was 6'4". So when I was like lecturing him, I was like, how's it going up there? Right. Other things, weight, your scores in a video game, right? Those things, more has a quantifiable moreness. There are times that we use numbers and they don't mean more or less. Can anyone think of an example of that? Yeah. Yeah, your student ID number doesn't mean you're more of a student or not, right? Social security number is a really good example as well, right? These are sort of randomly assigned or just like the next person in order. Doesn't mean you're more of a person because your social security number is higher, right? And in fact, the first 3 digits of a social security number, I believe, have to do with the geography of where you're born. Other examples, if you're on a sports team, your jersey numbers, right? Doesn't mean you're more of a player because your number is 99 and someone else's is 52, right? Subway train numbers, again, not more of a subway if it's the 6 versus the 4. And then if you go to Subway or Jersey Mike's and you order a number 13, right? That doesn't mean it's more of a sandwich than a number 2, right? Again, they're just sort of arbitrarily being used. Another thing we look at is equal intervals. Is the distance between 2 points on any place on a scale the same? So like, I'll give you an example here, a ruler, right? If I look at this distance right here, that's an inch, right? Between 1 and 2, that's an inch. Between 5 and 6, that's an inch. Between 10 and 11, that's an inch, right? Regardless of where I'm looking, it's equidistant. Another example is mile markers on the freeway, right? They're showing you tenths of a mile. Psychological tests don't usually have this property. And when we talk about intelligence tests in a couple of weeks, we'll talk about this in more detail. When it does have equal intervals, we can describe the relationship between the measured units and the outcome using a straight line. And it's just a simple algebraic formula. It's just y equals, making sure I'm using the same letters they do. Yeah, a plus bx. Just basically, that's the formula for a line. Woohoo! But again, this is not always the case, and often the relationship of scores will be nonlinear. So sometimes you'll have a quadratic relationship between scores, sometimes they're really random. And then the next thing we look at when we look at these ideas of measurement is whether it has an absolute 0. When nothing of the property being measured exists. So can anyone think of something that might have an absolute 0? Yeah.
Well,
It is hard.
might not be.
Yeah. So something in theory can have no mass, right? Yeah, that's the proper term. I didn't do well in physics, mostly because I had a sexist teacher. No, not even joking. Like, I would ask a question and he would say, I'm not going to answer that. And then a boy would ask the same question and he'd answer it on the board in detail. So not just like saying he was sexist, he was sexist. But yeah, so something like weight or height or heart rate, right? You can have 0 heart rate. It's not good for you when you have 0 heart rate, right? But you can have 0 heart rate. So as you're getting at it, and Caitlin kind of hinted at it, how hard it is to think of an example, there are not a lot of these, and in particular, not in psychology. So some examples of things that might be harder to determine whether there's 0 or not. Emotions, right? You ever actually have zero emotions? Is like just feeling meh an emotion? I don't know, right? Personality traits. So a lot of different psychological constructs, there's probably not an absolute zero. So there are these 4 different types of scales that we're going to discuss in more detail now. And the first one we'll talk about, which is commonly used in psychology, is nominal. And nominal is where the number just represents a naming, a label, an easier way to rename something. So nominal name, that's an easy way to remember it. The numbers can be completely arbitrary. So for example, you can have sex, 1 is male, 2 is female, but I've also seen people use 1 is female, 2 is male, right? And it really doesn't matter as long as you remember which one you labeled as which, right? Same thing for race, right? Caucasians don't have more race if we label them as 4, right? And so it's just an arbitrary number, an easy way to refer to this. There's no true zero, there's unequal distances, right? It's just a way to numerically say, these people fall in one category, these people fall in another category. And you might do this with things like, so I do this, I have a scale that you can actually diagnose whether someone has an eating disorder or not. So I can actually get a 1 equals diagnosis, 2 equals no diagnosis. Or most of the time I do 1 and 0. Again, arbitrary, doesn't really matter. Ordinal scales. So these are ranks. So ordinal, order, ranking order is a way to remember it. This tells us the relative order of our participants on the dimension being measured, but it doesn't tell us the distance between participants on that dimension. So it's not like a ruler. It's not like there's 1 inch, 1 inch, 1 inch, 1 inch. The distance between the numbers is arbitrary. So, you know, something like if we labeled A's, B's, C's, right, with numbers, and that's kind of what we do when we do GPA, right? We don't necessarily have like the same amount of people in each. We might even not have the same like distance between them, right? But the example I really like is like thinking of the Olympics, right? Thinking of like a track and field race, right? So we're thinking about the 5K, right? So the gold medalist comes first, the silver medalist plays second. But maybe the gold medalist, the first place finisher, came in at 16 minutes. And then the silver medalist, the second place person, came in at 20 minutes. And then the third place person was right behind the second place person trying to beat them. So they came in at 20 minutes and 3 seconds. Right? So even though that's the rank we're giving them, that's what they're gonna wear during the fancy gold medal ceremony, right? It doesn't mean they were equidistant in the time in between. And the same thing happens with really any sport. We can think of like football, soccer matches, right? You could win, 8-1. Rare, but it happens sometimes when the people are really off balance, right? And if someone else beats you 1-0, right, they still get the gold medal over you. And so magnitude or rank order is implied here. And sometimes, really a lot of times, Likert scales kind of fall here, right? Is the distance between strongly disagree and somewhat disagree actually the same as the distance between somewhat disagree and neutral? How would we even determine that? Right? But they do have a rank to them, an order to them. Then there's intervals. And this is where the distance between numbers is actually the same, again, like a ruler. But there's no true zero. So the example here is that Fahrenheit has a 0, right? This Fahrenheit measure of temperature has a 0. That doesn't mean the absence of temperature, right? In fact, as someone who grew up in the Midwest and has seen 0 quite a few times, there is a very noticeable temperature. It is cold, right? You don't go outside. Sometimes if people's hair is wet and you touch it, it breaks off, right? It's not fun. And it can be 30 degrees below 0. And I unfortunately have also experienced that, right? But that's still warmer than 50 degrees below 0, which is what it can be at the Arctic Circle, right? So again, it's not the absence of that. And then if you think about IQ scores, right? Like the lowest people typically score on an IQ test is 10 to 20, and that's even hard to get, right? So like a 0, there's no true 0. There's no like lack of any intelligence. So because of that, we cannot multiply or divide them. So if you remember back from math class, if you divide by 0, it's an imaginary number, right? And we can't really use that, right? And so this means we're sort of in theory limited with the types of analyses we can do. Now a ratio scale has the highest level of measurement. It does have a true 0 point. It can have a total absence. And so examples like we came up with before: weight, length. And again, here we have units that are the same. Blood pressure, right? Again, just like your heart rate, you can have 0 blood pressure. It's not a good thing, right? But it can happen. And again, if we think about just, are the units the same? 2 inches is double the size of 1 inch and half the size of 4 inches, right? So yes, you can do higher level stats with these because they have that true 0 point. That being said, in psychology, we kind of fudge it, and we'll use ordinal and we'll use interval stuff and do higher order stats. Just putting it out there. We do that. So basically, if we're looking at like the gold standard of measurement, we would say that ratio is better than interval, is better than ordinal, is better than nominal. And the scale of measurement used on one particular measure determines the amount of information actually provided by that measure. So nominal scales provide the least amount of information, and ordinal provide less than interval. Ratio gives us the most information. So again, nominal, if I tell you someone's a 1 on gender, unless you know my coding scale, that doesn't actually mean anything to you, right? Ratio is the best, again, because it has that true 0 and equal intervals being measured. Gives us the most information about the construct being measured. Now, the book makes a big deal about the distinctions between these 4 scales, right? But there's really only one distinction that matters, particularly in psychology. And I'm not going to make you all vote on these, but the correct answer is D, nominal versus anything else. Because in nominal, again, the numbers are arbitrary, they just mean a name. And anything else that you look at, we're at least getting a rank from those, right? Nominal, because they're categories, you cannot do most statistics with them. You can use them as a grouping. Let's say if you wanted to do a test comparing 2 groups, you use those numbers to distinguish your groups. But getting a mean on gender is meaningless, right? Because those numbers are meaningless. Again, ordinal is ranks, interval is like ordinal, and ratio is the best, but all 3 of them give you at least a rank order, and so we do higher order stats with them. Alrighty, so I'm gonna leave this up to y'all. Would y'all prefer to take your break now or do the activity and then take your break? Activity? Cool. Alrighty. So this is gonna use, it's math again. This is your last mathy one you have to do by hand. We're gonna do one more mathy one. but the computer can do it for you. And so some of this will be a little bit of a repeat from last week.
Remember last week.
That's okay. Sometimes I don't remember what I had for breakfast this morning, that happens. Yep, and then, some of it's gonna use the formulas we just looked at. The same thing as last week, if you have a question,
I don't.
feel free to ask me. You can work together, so work in groups or pairs, and I am gonna be chilling up here. Folks on Zoom, I'm gonna get you a link to the assignment here.
I don't remember what X is.
Yeah. Yep, that's it. All right, so folks on Zoom, this is going in the chat. And I'm creating a link where it should just copy it, open a copy for you. Yeah.
Yes, to the whole number.
Yeah, yeah, that's okay. Hang on just a sec, y'all. I messed that up. That's not gonna take you anywhere. This one will. There you go. That'll open it. Sorry, Zoom folks. Yeah. Yeah.
You want us to round two?
So typically what I round to is 2 digits. So 2 digits after the decimal place.
Can we get to the full number though?
Yeah, that's fine. Just make sure it's clear you're doing that. So when I score it, I know that.
So I'm gonna write the full number.
Yep, perfect. Alright. So what I'm actually gonna do is I'm gonna go grab your assignments from last week and start rating those.
So we're doing the exam class today?
Yes, I think so. I like on the break, I just need to touch base.
And on the syllabus, you said to schedule a meeting with you before tomorrow,
That's okay if you don't find something. Just like put it on the schedule, then you'll be good.
so I can do like next week.
Yeah.
Okay.
I could tell because I made all my classes tomorrow and so I had like 5 meetings in a row between 4 and 5 today.
So like, can I just like run the class early?
They've come for me.
So can I like come early one class to talk to them?
That's fine, just like shoot me an email and we'll do it that way. I'll be great.
I got 13, 17, 5, 0, negative 15, negative 15. Yeah, what's the answer? 169. 25. Sorry, how do you go from 169, 180 to 25? That's 17. So then it's 0 again. Yes, it'd be 60 and 61. What is the mean of the numbers? I don't know. You should hear it, asking for you. I'm gonna ask the question. What's so confused?
Oh, it's probably because I used the full function.
So we stick with it.
Because the full. Probably next. What is it?
Like when people.
Yeah, exactly, and it's numbered.
The city minus 1. What's the E?
What?
Oh, shoot, I don't have mine, wait, I might have. Let's see. Yep, that is right.
It's client.
So what do you wanna do for here, make sure you're putting this, and remember, when you square, these numbers become positive.
Because we're not finding the X.
Yeah, I think that'll give you the right value. Your mean is right, but then your standard deviation is not.
I'm confused.
I can hopefully help unconfuse you.
What do we do?
All right,
What is X?
so X is, this is X minus M squared. So you add up all these numbers and that gives you your top value. The E there means sums, and so when you add these up, you're summing them.
Okay, I see that makes so much sense.
Yeah.
Oh, so it was like calculating.
Exactly, yeah, so remember that we are looking, E just means sum. So if you add up the numbers in your X minus M squared column, that's your sum of X minus M squared. Yeah.
What did you get? I found out.
So there's a reason for this and I'm forgetting what. Correction for the N minus one acknowledges if you're not getting the whole. Yeah.
Okay.
That's like, so.
I got 960 again. 169 plus 289. What's that? Oh, it's 1.289. Yeah. Oh, I used some 189. So what's that?
No, thank you.
For what?
I have.
Oh, I didn't know.
So you want the square root of that?
No,
Oh, that's the other thing you forgot to do with six square root.
Oh. It's 9.
Oh.
It's square root of what's there, 6, 9. Enough one doesn't turn correctly. So you need to do the square root. 6, 33. That's good at least. Then it's 93. Is it fine if I just round everything up?
Yeah, that's fine.
I think you did the square root first. That's.
So the square root is of the whole thing, so you do the square root one.
And then you get it. Alright, so.
Yes. Exactly, so yeah, you take that sum of all your X minus M squared, you divide it by your N minus one, and then you take the square root of that number.
How bad it is on me.
That's okay, that's actually one of the reasons, this assignment used to not have the mean stuff on it, and one of the reasons I put that on here is to give a practice again.
Excellent. And wait, I'm not there yet. Two, that's 3.8. I have 14. Yes, 14, 6, 2, 5, 1. And then you don't have to see it. You get the 1.069 divided by 5. Maybe no. No, because asking what's next, where is this? Oh. You said you got 14.62. Well, first you get 2, so 8, and you divide it by and then you square root it. And then 14.62. Okay, see, that means 10 point 6 down, because that was many stress. You said what? What? Oh, I don't know, I think Bobby that. Is that like
That's a pretty good.
Bobby man? That's like a who? What monkey? Like on the boats.
Good job last week, everybody got a 10 on the assignment, I just graded that.
So. Let's look at it. I'm not remaining with 1 minute over. Negative 1.03. Parentheses, virtual percentile rating. So all you have left to do is the computer lab then?
Yep.
So like, as soon as everyone gets back, we need.
Well, what I was gonna do is give you 5-10 minutes to talk to your groups. And then, yeah, we'll go over to the computer lab.
The computer lab, the one in front.
There's actually one in this building, we'll just walk over to. Over in the social science lab. It's kind of hidden down there, it's like across from Dr. Martorell's office.
Well, next to the table. The wood thing and the chairs, like right next to the other door across the hall, they have the wood thing and the chairs. Oh, the girls on front. Yeah. Yeah, this calls for that.
It is across, yeah, it's not in the same hall as Dr. Ariel and Dr. Martorell's office. I was gonna try to do it on this computer, but this computer doesn't have a good.
What is the beef between the professors?
I don't know. Like, this is not me, so I don't know what's happening, but it's getting dramatic.
These are in support, one of their speakers, do not remove function, you can't remove function.
I mean, to be fair, there's a lot of furniture in here. Like, there are 5 desks up here that I don't know anyone can sit at.
Six.
Yeah,
Unless I
that's
have,
true.
like, a bad student who sits there.
I mean, most sure. Yeah, apparently, it's gonna be on the recording, so y'all get to hear the story too. Apparently while I was on sabbatical, I think it was while I was on sabbatical, there was actually like close to blows fight between 2 professors. Because one wanted they had like taught back to back, and one wanted the desks in rows, and the other one wanted it in a circle.
Oh, we just have to move it for Dr. Pate, Professor Pate, like.
Yeah, that's what I have my students do, is just move them and then move them back at the end of the class, but apparently they like almost gave the blows over it. And I was like, drama, children, come on.
Don't forget to erase the board before you get out.
That's true, I will get added to that. Who teaches it here on Thursday night? How dare you? Also, like, I don't mind erasing the board for the next person who comes in here.
All the entire board.
You said you erase it, I don't know. I do love that it's like, please erase the board after each class, do not erase.
I think it's
What?
Ted wrote that. I'm pretty sure it's Ted wrote that. Why can't you just draw a line down the middle of the board?
I'm just like, yeah. Cause there's too much passive aggressive energy and I just can't stand it.
It's been too
I teach 2 classes in this room, I don't need to deal with that.
top right corner.
It's like, it's not erasing, it's kind of like when you need,
It's like a wet rag.
that's what it is.
That's.
I just like leave it. I'm sure someone will write it back up by tomorrow or next week, but.
So what is the meetings with you allowed?
We just get to know each other, you ask me questions about the class, and it's really about you all learning my system, so if later in the semester you need to talk to me through the system, you know how to.
But it's required,
Yes. You get points for doing
like, I mean.
it, like 10.
Thanks.
Yeah, I got a lot of people scheduled next week, but
Can I not see you tonight?
yeah, we can do tonight.
Great.
That's fine. Sure.
I'm right now.
Well, let's.
Know about you, I'm for it, and I'm not leaving.
Yeah, today between 4 and 5, I had someone every 10 minutes. It was like, whoa, it's a lot. Oh, you're good. So yes.
So like.
Yep, those are so good. Yeah, definitely. Yeah, you just need to do it like I did it when I first. Okay.
So just.
Yep, exactly.
Here's today.
Okay, so. What I wanted to do is give you all a couple minutes to meet with your groups. Does everyone have at least one person from your group here? No.
No.
Well, let's just take like 2 minutes, 3 minutes to talk if your group is here, brainstorm about writing the questions, things like that. I'm gonna go down and double check to make sure the computer lab is unlocked and I don't have to call security. Or I can break it through SSL 111 because they decided I deserve a key to that.
What questions are we gonna ask? That's what I'm curious, that's not what I did. She's like, you do something. Oh, really? Question? Yeah. Well, like, how many questions? And we can't just post it on Instagram. You can say that you will. Wait, so why can't we just email people and put it on our Instagram? So I have questions like, are you sure? I really want to put it like on Instagram when we have the questionnaire, and she say we can do that. Well, I did that, so I'm really early on this, because if you just post a link to a Google sheet, then anyone can listen. But like us, we only want like some college students. So like if it's from anyone, then it'd be a lot broader. So you can. Can we ask them like on Instagram? Like failing options about. So like, how do you plan on this people when you reach? Versus people go that way, because that's what. So I have ADHD. But I can't go back. Well, he has ADHD, he said, "Oh, no, it's all right." We had 2 out of 180.
Yeah, sure.
Really came through.
It was a lot. No, it was a bigger number because I was still like 40 days. Yeah, she said have to. We have to like this to get practice. So we could just go to a ADHD testing center. But don't we have any number of ADHD or not? And like, we have said, the first. Well, so says. My sister. Six. What is that? The other one has that's not why we should. Oh, she may go back to place. But I have to want to.
Okay, using the scale.
Okay, that's integrity. You might. I mean, he's an idiot for not like. Do you remember tweeted? That's not her thing.
Yeah.
We want to have pregnant. Yes.
All right, any other groups have questions?
No questions. How many people have to fill out the survey?
30.
Oh.
Yeah.
So we probably do like, we're doing 25.
He's an idiot for not seeing students.
Oh, that's a good question. So this is controversial, ever been meeting for people. So, reflected it in order to publish your media on, but you can calculate for my height. And more and more people are moving us out of that because of like the racist origins of Vietnam, which is like it was made by a mathematician to study through, and then it was used for eugenics. Right, so. But it is traditional collecting, so if you're interested in collecting it, it's a good collection, and then I can give you the formula to convert it to D5.
But everyone in the comments.
Yeah.
It's a not really.
You know what? There are what it's called, secret rings, where there's like a range of bodies, and they can circle where they and they can also like where they want. So that might be a nice thing.
He's fucking for real.
Exactly. It's kind of a measure of.
Negative 0.001%.
Exactly, yeah, so I mean, yeah, that's the Australian number. Because that was-
So like, be a fucking Virgo. And everyone in the comments is going off.
Yeah. I know you can get them everyone, but so that they would be not good to wire, so which I don't think
I'm sorry.
you should have like now, like anyone before we use it, and then they changed it, so like you can make 2 people's insurance. No, so now I pay for my own pocket, but it's just a better money when what I do.
That's paid for that, I couldn't pay no way.
Yeah, I think we might be able to do it with I'm almost positive I could not do it. Okay, any questions?
You know, I just saw swaying. You be hungry, you don't need money's hurry. When was the first, what was the age you first got a credit card?
Money and.
I think we got one when I went to college, so like, so it's not, I had a debit card when I was up.
See, I have both,
yeah.
but I didn't know the first thing here, I had a credit card and it's not saved there.
I got like,
The first 2 months.
I got like 3 when I was in college, and that was a bad idea.
For the first 2 months, I didn't pay anything. Now I have like $48 I need to pay off.
Alrighty. So the computer lab is open, so we're gonna head over there. Folks on Zoom, I'm gonna sign off this computer and then sign on the one in there, so just stay on the Zoom for a couple minutes. All right, Julia, you're now the head of it.